Let's get started. So, today's session is on PySpark. We've already been over Spark. Spark allows you to work in parallel, it allows you to work with your distributed data, and it allows you to perform a lot of tasks much faster. And again, Spark is available in, well, you have APIs available in different languages. The one that we are going to go over is PySpark. So, PySpark is an API to Spark that is available to us in Python. Since we are well familiar with Python already, and particularly since we've been over pandas, so this is a wonderful tool to cover because eventually you'll realize कि इसकी majority commands जो हैं they are just like you would do with pandas. However, the underlying infrastructure itself is quite different. Today's session should not take more than, I believe, roughly 30 minutes approximately. So, all right, let's get started. To quickly walk you over the architecture that Spark deploys, and this is not specific to PySpark, backend पे Spark में होता ऐसे ही है. You have your driver program, and you have to initialize a Spark session, and then you have a cluster of nodes that are working at the back end. It can either be across multiple systems, or if it's for one system, so then you can have threads implemented in the same system. So you have different worker nodes, each with their own cache and each with their own tasks that are assigned to them. And then you have a cluster manager, which is responsible for dividing tasks between these nodes. And well, we will not get into the complexity of how these tasks are divided. With that, let's move on to our code. I'm just going to slightly zoom in here, and I think we should be all right. Okay. So I'm going to install PySpark. Actually, मेरा already be installed है, but since I want you guys to be able to, download this notebook and run the exact same command too, so you're going to install it and then you are going to import PySpark का एक module है SQL. From that, you're going to import Spark session. Essentially, there are lots of modules available, but we are only concerned with, well, we're going to go over basic data exploration ke commands, then data cleaning. We will not cover data visualization in here, and then we will cover data modeling as well. So this is all that we cover. Now you would want to initialize a session. So Spark session dot builder, you give an app name and get or create. Say if you already have an existing session under this name, it will just load the same session, which I think I should have. All right, then if I simply print Spark, I will be able to get some information about my session, including the version, the master node. I am running this locally right now, इसलिए I'm getting local, and then the app name, which I just initialized as test over here. If we quickly look at the type that this gives you as well, okay, PySpark.sql.session. Okay. So now let's load our data. I have a file available right over here. This, by the way, is synthetically generated data. ये actual में कोई भी available data set नहीं है. So I have the data set for patients of heart disease basically. I have their age, gender, chest pain type, resting blood pressure, cholesterol, fasting blood sugar, and then resting ECG, max HR, angina, and etc etc. And then I have target, and target represents whether they have heart disease or not. So I have 0 and 1. Target is essentially the column that eventually I would want to predict as well. All right, so let's read this into a data frame. You will realize कि अब सिर्फ कुछ commands different है. Now I initialized Spark already, so I'm going to say spark.read.option. Option के अंदर you have some parameters. I'm setting header to true, एंड सेटिंग हेडर टू ट्रू डज एग्जैक्टली दिस कि ये आपके हेडर में जो नेम्स हैं इन सारे कॉलम्स के ये यूज होते हैं, वरना इट विल जस्ट असाइन नेम्स टू माय कॉलम्स बाय डिफॉल्ट एंड आई डोंट वांट दैट. Then of course .csv, and you just specify the path to your CSV over here. If I was on Kaggle instead, I would have had that path. And so let's see what this gives you. If I just write df, so इससे आपको इसने दे दिया exactly all the data types of the columns that you have in your data frame that you've read. Essentially ये सिर्फ header देता है. And one important thing to notice is that by default, and this wasn't true for pandas by the way, so for a PySpark data frame, by default, everything is interpreted as a string. And then, of course, you have commands to change these data types. जब हम pandas use कर रहे थे, तो it would often interpret your entries as objects or as floating points or int64, and then you had string as well. But isme by default everything is a string. Even ch is a string, and most of my columns are, in fact, all of my columns are actually numerical. So let's see a few basic commands. df.count gives you the number of rows, and pandas ke data frame ke liye, this is what we used to do. Or we used to do df.size, and that would also work. But इसमें ये attribute नहीं exist करता. Let me just quickly try out for size, though yeah, that doesn't work for a PySpark data frame either. So this gives you the count of rows. I have generated 1000 rows. And then instead of dot head, you have a command that is called dot show. And dot show will basically show you the top however many entries you give it as an argument. All right. So if I write 3, तो ये इस format में मुझे सारे columns के across first 3 rows display कर देगा. Another interesting thing to notice over here is that it hasn't given me the index, which I used to get in pandas. So let's see what happens if I remove this 3. Now it will give me the top 20 rows. In pandas, by default, you get the top 5 rows, but you have to specify 5 for that. Anyway, let's move on. Now, in pandas, if you wanted to select a particular subset of rows, so I would just, sorry, a subset of columns, so I would just specify the column names as a string, and I would put all the strings in an array, then I would pass the array to my data frame and that would work. But यहाँ पे it doesn't work. Essentially, as opposed to that, you have the dot select command. Dot select command के अंदर either you can give one column which will just select that column, and then suppose I'm showing the first 3 rows of the column age, and इसकी data type भी नहीं change होती. So as opposed to in pandas, if you were to just add one single string, it would give you a series. And then if you were to add an array of strings, तो आपको data frame मिलता है. इस case में either way you just get this data frame. Alright, so similarly here I have just added an array instead, and everything else remains exactly the same. All right, now if you want to look at your columns and you want to understand the data types of your columns, this is how that works. So if I write data frame dot print schema, and in pandas we just had data frame dot columns. So अगर आप print schema का command run करें, this is what it gives you. This is the structure in which your data frame is stored. You have a root, and then under the root you have, well, essentially अभी जो आप पैटर्न फॉलो कर रहे हैं उसमें आपके पास इस तरह सिर्फ एक एक कॉलम है inside your data frame, but essentially this supports schemas where you could have nesting as well. Nesting would mean that within age maybe I have 2 further subcategories, but we're not going to cover that right now. So I have age, and then also it gives me the data types of all my columns, and abhi by default, like we discussed, everything is a string. It also tells you whether the given column accepts null values or not. And by default, all columns will accept null values unless you particularly specify it as false. So alternatively, I have a command df dot dtypes, data types. ये वो command है जो आपके पास pandas में भी available होती है. So this will give you all your columns in the format of tuples. And tuples के अंदर पहले you will have the name of the column and then you will have the data type of the column. I can leave both of these here. And let's move on. Now, if we want to get PySpark to infer data types by itself, so you pass it an argument which says infer schema equals true. And let's see what that gives us. अच्छा अभी इसमें एक problem है. This is what I was telling you guys about. If you don't specifically give it the header argument, तो ये column names खुद assign कर लेते हैं and it assumes that these are just column values. So I'm just going to fix this by setting the header equals true. All right. And now of course I want to see कि मेरे पास क्या data types हैं. All right, so now it has been able to infer them like I would have wanted it to. See, integer for age, gender, chest pain type, resting blood pressure, cholesterol, and then old peak के लिए उसने double assume किया है because you do have see you have decimal values in this third last column. So I've just added over here. Note that column names are not read if you don't set it to true. With that, let's move on. And interestingly, if you don't want it to infer schema itself, तो आप particularly भी data types को specify कर सकते हैं. So you can just create the schema. And this is the format that you follow for schema. It's just one big string. String के अंदर you have the name of each column separated from the other by just a simple comma. So I have age and age के आगे now you have a few data types जिनके लिए you have reserved words such as integer, string, I believe double as well, and then I don't know इसके अलावा कौन सा होता है. You can experiment with it. So then I use my spark.read.csv command. I give it the path of the CSV, header equals true, and then I have one other argument which is schema. So उसमें मैंने अपनी ये schema वाली string pass कर दिया. And now if I look at the data types, so it's exactly all those that I assigned to it. But rather I'm going to move this command down because I think के बाद में modeling के time पे problem हो सकती है. If I have certain strings, I can't just pass strings to a regression model. So I'm just going to pass this here. Okay. And with that, let's move on. Oh yeah, of course, if you have null values in your data set, so there is one very cool way of handling these too. आप जब read कर रहे हैं data frame, उसी में you have an argument null value, and null value के अंदर whatever you pass by default when reading your data frame, it will just set all the null values to NA. Alternatively, I could add a question mark over here, or I could add a dash over here. So ये भी आप कर सकते हैं. Again, I'm going to run the infer schema command because I don't want कि बाद में I get an error. Oh yes, of course. Writing it or like saving your data frame. In pandas, you have a simple command that goes something like this: df.toCSV, and then आप CSV की path specify करते हैं, and then there's one argument which you pass to not store the index as a separate column. Alternatively, for a PySpark data frame, you have df.write dot format. फिर format के अंदर you're specifying CSV, and then you have dot save, and dot save के आगे you specify the path. However, this particular command, it does not let you overwrite an existing file. If you want to overwrite an existing file, like if I'm gonna use the exact same name and I want के exactly मैं यही name use करूँ और वही वाली file overwrite हो जाए with this new data frame, so then I would have to set the mode to overwrite. So it's the exact same command, but before save I have dot mode and overwrite. Let's try running these two. So path may let's try giving it the same path. Patient data. I think that should be all right. I don't get what happened. I think let's do it this way. Let's change the name. All right, you know what? I'll just look into this. Although I do want to try the next one out now. इसको भी एक दफा try कर लेते हैं. Dot write dot format. Okay, I'll look into this and I'll update these commands before sharing the notebook with you guys. Probably there's something that I'm missing out in the path, maybe. Anyway, so just I want to give you a high level view of how a pandas data frame is different from a PySpark data frame. There are a few things that we have looked at already. Like आपके कुछ commands different हैं, कुछ format different है. PySpark में you can do nesting. Pandas में, well, as far as we've studied, you cannot do nesting. And then, of course, ऊपर से it feels like everything is the same except that the commands are different. But at the back end, PySpark is employing an architecture that supports parallel computation. And a lot of those details are not visible to you. आपको एक बहुत abstract सा view मिल रहा है इसका. But at the back end, this is what is happening. PySpark data frame is going to use a particular kind of execution, which I'm sure I named in the last lecture as well, and that is called lazy execution. It optimizes by planning ahead and it essentially creates a directed acyclic graph. And we already know what a directed acyclic graph is at this point. So एक आपके पास original data है, and then every single time that you apply a transformation to the data, we know that you have several transformations available. Even just then आपके पास एक cleaning की command है, so that's also a transformation that you're applying to your data. If you're filtering out some rows or you're grouping your data, you're still applying some transformations to your data frame. All right, so for all of these transformations that are available to you, आपके पास वो back end पे एक directed acyclic graph बना लेते हैं. It constructs a graph, and then there are two kinds of commands that run. You either have transformations or you have actions. Transformations वो perform करता रहता है. It doesn't update your original data set. It keeps your original data set as it is and आपको transformation perform करके output show कर देता है. But when you have an action command, then it modifies the existing data frame inside your hard drive as well. Essentially इससे आपको फायदा ये हो रहा है that you are doing whatever you want in memory, and we know that that is an advantage that Spark overall offers over MapReduce, because MapReduce involves a lot of hits to your hard drive, so this does not. And then for this you have separate commands. For instance आपके पास dot cache की command होती है, which will load all your data again from the hard drive to your cache. And then you have another command dot collect, which will collect all the data from your worker nodes and load it onto your जो आपका local, that, what is that thing called, yeah, your cluster manager. Typically we try avoiding these commands. Actually हमारा data set तो बहुत छोटा है, so it doesn't really matter. Generally we try avoiding these commands because then if you have a very large data set available and you can't load it all at once, so this is going to be problematic for you. All right, for now if I run it, it's going to run fine. It doesn't give me anything that's different. And just on that note, df.collect की जो command है, you generally do not use these separately, but then there are certain commands within PySpark that do perform this operation at the back end. And अभी इसने सारा data set जो है यहाँ पे मुझे load करके दिखा दिया. All right, with that, let's move on. If you want to convert a PySpark data frame to a pandas data frame, you have a very simple command for it, df dot to pandas. And इसी तरह आपके पास to array की command भी होती है, and this is what it gives me now. So now if I do pd dot head, see, this is what I get. And personally, I like this interface a whole lot better. And then of course बल्कि इसको हम यहीं पे रहने देते हैं for our information. And then if I have a pandas data frame and I want to convert it to a PySpark data frame, तो उसके लिए भी I have a very simple command, and that is spark dot create data frame, and then I just pass my pandas data frame to it. And this is what I get. Oh yes, of course. If you want to change the data type of a column, इसके हमने दो तीन methods देखे हैं. You can either infer the schema, or you can specifically, when reading the file, you can give it a particular schema. Alternatively, if you just want to change the data type of one column, अब आपने data read कर लिया हुआ है, now you don't want to change it at the time of reading, but you want to do it later. So for that, from within the PySpark.sql module, you have types. Types के अंदर you have several data types available for typecasting. For instance, float type. So if I want to convert age to float, this is the command that I will be using for it. df dot with column, then I specify the column name, then df dot column name dot cast, and then float type is a function which I pass to it, and ये एक एक वैल्यू को age में से लेके type cast कर देगा to float. Are there any questions at this point? I thought that this should work. Oh yeah, okay, it's not a function. Okay, so there are no questions. ठीक है, now let's quickly check कि see now age is a floating point instead of an integer. With that, let's move on towards data cleaning. So how do you remove a column? अब ये वाली command जो है आपकी, it's exactly the same as the command for removing columns in pandas, df.drop. And then drop के अंदर you're just specifying the column name. I actually don't have a column name called age fixed. I think ये मैंने create ही बाद में किया था. So let's just try it for another column. I mean, exercise engina. All right, with that, let's see. Oh, another interesting thing is that either you don't really have to specify the in place argument as well. By default, it will apply this in place. If you want to apply it out of place, so you're actually going to have to create a separate copy, a new copy, जिसके ऊपर आप ये operation apply करेंगे. Anyway, now if you want to rename columns, this is how you would do that. df dot, and I think in pandas you have df dot rename, and then you have columns equals, and इसके अंदर आप एक dictionary दे देते हैं. So for instance, column 1 previous, and then column 1 new. So you pass a dictionary in this format and वो rename कर देता है, and then you have to specify in place as well. So here you just have df dot with column renamed. The catch is that you can run this command for only one column at a time. इसको आप सारे columns के लिए एक ही command में नहीं run कर सकते. जिस तरह in pandas you would have just done df dot rename columns equals, and then you would have given it an entire dictionary with all the columns that you wanted to rename with their previous and their new names, and that would have worked fine. So either you have df dot with column renamed and you give it the new name, comma the old name. Just verifying that I've done that right. Hold on. So इसके बाद हम data types display करके देख लेते हैं. No, so I've actually written it the other way around. It converts a column with this name to this name. All right, with that, let's move on. Okay, yes, there we go. So ये आपके पास अब capital A से age आ गई है. However, if you do want to rename multiple columns, you actually have to do it in a loop. Now I'm creating name pairs, and name pairs के अंदर it's basically just an array, and it's an array of tuples. उन tuples के अंदर मैंने इस तरह specify किया है old column name, comma new column name. And then this is how well I can run a simple for loop for it. Luckily, Python allows us to do this very nicely. For old name, comma, new name in name pairs. So ये by default एक एक tuple उठाएगा from name pairs, and then the first index of the tuple will be read into old name, and then the second index will be read into new name. And then it's the exact same command. Df equals df dot with column renamed. Oh, I think you do have to receive it in a data frame. My bad. ये आपने receive करना होता है. Otherwise, you're just running the operation at the runtime. It's a transformation, but then it's not an action. All right, anyway. So then I've specified old name and new name. Similarly, if you want to display the summary statistics in your data frame, so you have df.select and dot select ke andar. So dot select me you can select a bunch of columns, and after that, after selecting them, and by the way, if I wouldn't have selected anything, it would have run for the entire data frame as well. So I have dot describe. Describe key command is also available in pandas, but then I also have to add dot show ahead of it. All right, and this is what it gives you. It doesn't give us exactly the same summary statistics जो आपके पास pandas में आ रहे थे. Here you don't have the percentiles. You just have the count, the median, the standard deviation, the min, and the max. Are there any questions up until this point? All right, no questions. So let's move on. Next, we would want to handle missing values. There are several ways to handle missing values. Suppose आपके पास age का column है, उसमें you have missing values. Can someone here very quickly tell me about two different ways of handling missing values in your column? Anyone, people? I have like seven people in this meeting, and I'm pretty sure everyone should know. So, how do you handle missing values in your data set?
We can either drop those missing values or we can impute them with like the mean or the median if it's like a numerical value, or a mode if it's like a categorical value.
Precisely, perfect. Thank you, Rohan. So either you can drop the missing values altogether, या फिर you can impute them. You can replace them with something. इसमें you have forward fill, backward fill. You can impute it with the mean, median, or the mode. You can even impute it with the max or the min. So anyway, let's look at different commands that you can use over here. So पहले you have df.na.drop, which will just drop all the rows that contain any null values at all. You know what? I would just like to put this in a different cell so that even when you're trying it out, you can try it out for yourself. Okay. So anyway, df.na.drop will drop all the rows जिनमें कोई एक भी missing value है. So if you have 11 columns in total and there is a row जिस row में 11 values में से एक value missing है, तो you will drop that row as well. And then you have df.na.drop how equals all. This will drop the rows that contain nothing but null values. So यहाँ पे जो command है उसमें सिर्फ you're specifying one argument, you're setting one parameter to all, and that changes everything. Now it will only drop the rows जिनमें 11 की 11 values are all null. Either of these are two extremes. Then, of course, something in between is specifying a threshold. So, if you specify a threshold of 2, then you're going to drop the rows that contain two or more null values. And of course, lastly, you can specify how, when how equals any jo hai, it is like the same as this command basically. So, this drops the rows that contain any null values. Okay, my bad. Yes, and then you can specify subset. So अगर how equals any के साथ मैंने एक column का subset दे दिया एक columns का जिसमें I have age and resting blood pressure, so then it's only going to drop those rows for which any of these two values is null. All right, so if I have a row जिसमें 11 values में से age या resting blood pressure में से कोई एक भी null है, उन rows को ये सिर्फ drop करेगा. So a quick question, how do I drop the rows where all columns in my subset of columns are null? What will change in this line of code? Now I want to say कि सिर्फ उस condition में drop करनी है when age and resting blood pressure are both null. So there's only one small thing that changes here. Can someone tell me what that should be? Come on, people, anyone? Right now, what my command is doing is कि it drops a row जिसमें either of these two values is null. Now I want to drop it only if both of them are null. How do I do that? So in how you'll just specify all instead of any, and then it does exactly that. All right, and then of course filling in missing values. अब filling in के दो तरीके हैं. Either you can fill it in with a random value, or you can fill it in with a more meaningful value. So I have bf.na.fill. उसके अंदर you specify the subset of columns for which you want to fill in missing values, and then it replaces it with the value that I'm specifying. अगर मैंने question mark specify किया हुआ है तो it will just replace all of them with a question mark. Alternatively, I can specify null, I can write dash, plus, or anything for that matter. And that will work too. And then, of course, a second way, which is a less crude way for filling in missing values, is to replace them with something more meaningful than just an arbitrary number. For this, you have to import from PySpark.ml.feature. From this module, you import the imputer. And then, of course, you have to initialize the imputer. And then जब आप imputer को initialize करें तो you specify the input columns, the output columns. Input and output are the same because I want कि age के column के अंदर ही ये transformation apply हो जाए. If I wanted to apply a transformation to the column age and then I wanted to store it in a new column, transformed age, तो फिर ये output columns का name would change. And then dot set strategy may I have mean, but of course there are other strategies available for you to experiment with as well. Once you have initialized your imputer, so then you have df equals imputer dot fit. Fit ke andar you pass your data frame and then dot transform in which you also pass your data frame. Seems fairly complex for a very simple operation. Pandas mein this was pretty straightforward. So it's just I'm quickly going to run these commands as well. Although I don't think that my data contains any missing values for this particular example. So with that, let's look at how you can query data. Queries में आपके पास filtering queries आ जाती हैं, and then you have sorting, you have grouping and aggregation, of course. So this is how you simply filter data. df.filter, and then filter ke andar as a simple string you specify, well, whatever query it is that you want to apply. So if I just write dot show, so I think that this should work fine then. All right, it still displays only the top 20 rows. I haven't stored it anywhere separately. I could have just as well done this anyway. So now it has filtered out all the rows where the age is greater than 10. अब आपको ये एक simple string में command जा रही है. Alternatively, you have an alias for the filter command which is called where, and that works just as well. ये exactly basically ये SQL की command है where. Alright, so if I do this instead, and then I can do dot show. So this will perform the exact same operation as above for me. Of course, I've specified 18 instead of 10 this time, but that shouldn't really matter. And then df.filter के अंदर you can pass a string, but df.where की command के अंदर you can specify a query in the format that we've always followed as well. So ये pandas वाला format है. Maybe some people would just be more comfortable using this. So df age greater than 18. And this is how that works. All right, then of course you can have aggregated queries as well. Aggregated queries में you can have the and operation or the or operation, and I'm using where for this. And where के अंदर बस एक bracket के अंदर you are specifying all your entire query, and now the format is exactly the same as pandas. So and के लिए you use ampersand, and then this is what you use for or. In the first query, I'm obtaining all the rows where the age is greater than 18 and the gender is 1. In the second command, I'm obtaining all the rows where either the age is greater than 18 or the gender equals 1. Why don't we quickly display this result as well? All right, are there any questions up until this point? All right, so let's move on. Then you have your negation operation. ये भी exactly pandas वाला है. I've used dot filter for this. Alternatively, I believe that dot where should work as well with negation. Yeah, so I'm just going to write down over here. Dot where will work the same so that you know. Negation means like every all the rows that do not specify this condition. I just want to obtain those rows now. Next, you have grouping. So we have the simple group by command, exactly kind of the same as pandas. I have particularly imported PySpark के SQL functions module में से column. Oh, actually, I forgot. You don't need that over here. You don't need this any longer. Then I changed the command later. So df.group by age and calculate the mean of resting blood pressure for each age. And then just like displaying the top three. Alternatively, अगर इसको सिर्फ show आप pass कर दें, तो this is what that result looks like. So that's grouping. And then you have sorting. Sorting के लिए you have to import a function. Here I've imported descending. I believe that you can import ascending in a similar manner as well. So now I've stored my group by object somewhere too. df.group by age dot mean. This means कि age से group by करना है, and then for every other column you have to calculate the mean. Later I'm selecting age. Alternatively, I could have just calculated the mean of age initially. After you have done this grouping, so separately I have applied the operation of ordering. So order by and order by descending. Descending ke andar you pass this, and then I can just select show, and this is what it gives me. Now all my ages are sorted as well. With that, let's move on to modeling. So first of all, when you're modeling your data, you perform a train test split. I've already imported this super, so you have df.random split. Random split may you give an array which gives you the proportions that you want to ensure for the random split. So now 80% of my data randomly will go into the train set, and then 20% of my data at random will go into my test set. If I just quickly display train over here as well, so this is what that will look like. Exactly उसी तरह आपके पास data frame है. And then of course you have 20%, so 200 rows for testing and 800 rows for training. For ML, PySpark does not accept columns of features, so these are just certain conventions. You do not need to memorize or remember these. Uh, आप पहले जब यूज कर रहे थे simple pandas or stars models or whatever it is that you were using for training, so you would simply just specify the column names. Now for PySpark, आप directly column names नहीं भेज सकते. Instead, it expects vectors that contain the attribute for each row. So आपके पास vector format में एक row जानी चाहिए, and वो एक row लेता है at a time. So I've specified all my column names, and then from PySpark का ML module, I have imported the vector assembler. I initialize my vector assembler जिसके input में I just give the X column names, and output में, well, this fvec is feature vector. Then I have my dot transform command. So very quickly, I want to show you what the data frame looks like as well. अच्छा अब ये नहीं वर्क करेगा because once मैं अप्लाई कर चुकी हूँ. Varna, this command ran just fine right now. So let's try this again. Rather, that's weird. Then I'm going to clear the output for now. And let me just check if you have a. Oh yeah, of course. The problem is that I'm overwriting my data frame itself. इसीलिए the same thing is not working any longer. So new data frame equals, and then of course wherever this is, I'm just gonna move on from it for now. So df dot show, and this is what you have. So it's a slightly bizarre format to interpret right now. लेकिन आपके पास essentially हुआ सिर्फ ये है कि उसने एक एक रो लिया और उसको वेक्टर में कन्वर्ट कर दिया, and that's all. Then for modeling our data, I have imported ML regression module for PySpark से मैंने import किया है linear regression. And then I have specified my label column and then my features column, which has already been generated. And then I apply this to my training data. And of course, right now it's giving me an error because of, well, the exact same reason. So I'm going to stop over here and I'm going to fix this and then upload this. I'm going to sum this up though. Eventually आप मॉडल के coefficients को print करके display करके आप देख सकते हैं. You can do it for the intercept of the model as well. And then for evaluation, you have a dot evaluate command to which you have to pass your test data set, and then you can just display the predictions. Using the predictions, you can calculate whatever matrix it is that you want to calculate. Uske liye we're gonna have to add a separate piece of code, which I will before I release this. So are there any questions at this point? Okay, as long as there are no questions, that will be it as far as PySpark is concerned. Just a quick announcement before we wrap up, since I'm going to upload this in recorded form as well. PySpark key coding will not be tested on your final exam, so you are not expected to memorize any of these commands at all. Alright, guys, see you Monday. Allah Hafiz.